Stuck between a rock and a hard place. We all know that at age and nobody wants to be there. But imagine being stuck in space. Now that fear was unlocked quite recently for all of us when Sunita Williams and Butch Wilmore were stuck in space for 9 months extra than intended. Imagine what they were going through both physically and mentally. And who better to ask that other than Scott Kelly, American astronaut who spent 18 months cumulatively in space over 4 different missions. Scott, first of all, pleasure to have you here on CNN News 18.
Thank you.
You know, for us ordinary individuals, we can't even imagine it. But since you're the best brain to talk about it, I want you to detail what do you think would have happened to both Sunita and Butch, because these 9 extra months they spent from what was supposed to be a week were unintended and unplanned. While you go through a lot of training for something like this and you have your institutional knowledge and everything, what do you think they would have had to encounter?
Well, they have both been crew members on the space station before, so they had prior experience of having a long-duration flight. They both had training prior to this mission. So even though they were expecting to be up there for, I think, 8 days and wound up being there for nearly 9 months, they were very prepared for it, and it was their job, and they're professionals. And even though I have not spoken to either of them since they've returned, it seems to me like they handled it pretty well.
And the space station, everything else is prepared for these kind of eventualities, even a 9-month extra time for 2 extra persons on board?
You know, the space station is a pretty capable facility. And when it was determined that they couldn't come home on the Boeing spacecraft, what was decided was to launch another spacecraft that launched, I believe, in September. And they normally would have had 4 people on that flight, but they removed 2 of them, so they would have room to bring Butch and Sunny home. So in that case, with regards to like resources and things, it's not like the space station needed extra food, more oxygen, more water, more ability to scrub the atmosphere of carbon dioxide, because they still had the same number of planned crew members on board. What was different would be things like personal items, like clothing. But, you know, there's a lot of, you know, often there are resupply vehicles going up there, and I'm sure they've sent the stuff that Butch and Sunny needed.
You know, Scott, you were part of that historic twin study, along with your brother Mark, who's also an American astronaut. And it gave us fascinating insights into the changes that the body physically goes through. But I think the highlight of the study was, from what I could understand, is that you recovered fairly well after you were back on Earth, isn't it?
Well, there was the science that in many cases was genetic research. There was research in like human behavior and performance. So they did get interesting data on that. As far as my recovery, though, I've flown in space 4 times, 8 days, 13 days, 150 something, and then 340 was my last mission, so progressively longer. And what I learned was that the longer you stay in space, the harder it is to recover from it. Right. So on this last mission that was 340 days, it probably took me about 8 months to feel like I was back to normal.
And what was those things that were not normal when you came back?
Well, you know, immediately as you get back, I mean, gravity is a very strong force. Our physiology evolved with gravity in mind. As an example, our heart and our whole cardiovascular system is designed to fight gravity, to push the blood that nourishes our vital organs, our brain, in the direction opposite of gravity, up towards our head. So when you get to space and you don't have that force anymore, our heart doesn't have to work as hard, our vessels don't have to constrict as much to keep that blood up to where it needs to be. So it gets deconditioned.
Yeah.
In my case, my heart lost 25% of its mass over the course of that 300.
Like physical mass.
Yeah, it got 25% smaller.
Yeah.
So even though you do a lot of exercise, it still doesn't replace the exercise it does every time it beats to force the blood against gravity. So That was one of the most concerning things, I thought.
But you lose bone mass, you lose muscle
bone mass, muscle mass. If you didn't do any exercise, you'd lose like 1% a month of each of those. But we exercise, but you lose that. But I would say, the initial symptoms when you get back are dizziness, nausea. Because of my deconditioning of my cardiovascular system, my legs would swell up when I would stand up. I had hives and rashes anywhere my skin had touched. Once I got back, touched anything with any kind of pressure, because you just don't have that pressure anymore. And it was almost like an allergic reaction. You're tired. When you're in space, you don't need as much blood volume. You don't need as much fluid, because the fluid is redistributed. Like now, like we have a lot of fluid in our legs, because then you don't have that as much in space. So you lose that blood volume. But what you also lose are the red blood cells. So when you come back, you get the volume back quickly when you rehydrate yourself. Makes give you an IV. What you don't get back are the red blood cells. That takes months. So you're tired. And then I would say the last thing that you get readapted to is just the pace of living back on Earth in your normal life. When you're on the space station, everything is kind of scheduled for you. There's a timeline. It's kind of hard to get used to initially, where it's telling you what to do at basically in 5-minute periods of time for, in my case, nearly a year. And then when you get home, you really don't have that anymore, and it's kind of hard to get your sense of direction and motivation.
Yeah. Did you spend like a week in bed once you came back?
No, not at all. Yeah, you have a pretty significant rehabilitation period that goes on for, a few months. You have debriefs you have to do. You have medical tests. Yeah. So, you don't get time off for a while. It's actually pretty exhausting when you get back.
So when was the first time after, let's say, your longest trip, which was a year, that you feel like, okay, now I can, kind of just put that behind me and kind of, I don't know, rejuvenate and not think about it?
And I don't really recall when you start getting time off. I would say it's probably somewhere between the 2 and 3 month period.
Wow.
But still, the debriefs and the medical tests, they go on for a while. Actually, I still do them sometimes. All astronauts have an annual flight physical, but because my flight was particularly unique in the duration, even though it's no longer the longest flight, but at the time it was, and because of the study with my brother and I, for the rest of my life, at times I will do science data collection for a lot of these studies.
Are you still part of that study? Is it still a long-term study to examine the effects that you have long-term?
Absolutely. As a matter of fact, this last SpaceX mission that flew over the poles, it was the first flight with humans to go over the North and South Pole. On that mission, there was an experiment that actually had my brother and my cells on board on that particular spacecraft.
Again, to figure out what is the impact for someone who's been in space and someone who's not been in space for as long.
I don't know this particular
twins.
Experiment, what exactly it was investigating, but generally speaking, the experiment with my brother and I, called the twin study, used him as a control. Because and it really had less to do with the fact that he was an astronaut and more to do with the fact that they had decades of data on us already.
Yes.
And he could be a very good earthly baseline data person. Now, I'm sure there may be science-minded people or even scientists watching this, and they'll say, well, an experiment with only one sample is not statistically significant, but this is considered a longitudinal study where, over time you're compared to yourself, I'm compared to him, and you get more data points, which can make it statistically significant.
Well, twin studies are by far the most interesting studies in science, isn't it? Whether it's you versus your brother and the whole space aspect, or even on Earth, how different people age and with the same genes, etc. So let me ask you, given what you went through, and it's a process to feel back as yourself. What do you think is in store for both Sunita and Butch right now?
Certainly, their mission was a little different than mine. Because they were expecting to be up there 8 days and probably figured they could wind up there longer, but probably weren't thinking they'd be up there for 9 months.
Yeah.
But they're professionals. They were prepared. So I'm sure the homecoming was really exciting for them, maybe a little overwhelming. And, the debriefs and the rehab are challenging, but, they'll get through it.
But tell me, for our viewers watching, a lot of us, look at astronauts and we are so fascinated, right? We want to be there, but then we wonder whether we can do this or not. Or even, do we even want to do it? Because I'm sure there are sacrifices involved. So apart from the hard work that it takes for you to get there, now that you've done your space days behind you, what are the sacrifices that you had to make just to be in space that will never go away while you're here on Earth?
There's a lot of family sacrifices, I would say. It's challenging on relationships between spouses. It's challenging on relationships with kids because you travel a lot for training. You're away a lot. Even when you're home, you're busy. Sometimes even when you're not at work, you're busy studying, preparing, getting ready for the mission. So there are those challenges.
Physically, though, what do you think you will never get back?
Oh, my vision.
Yeah.
I have, as an example, I have a distance correction that my brother does not have, and even though we're identical twins, so that seems to be due to the longer duration of time I spent in space, because in the absence of gravity, you do get, your head swells up. You feel like there's a lot of pressure in your head, and that affects the physiology of your eyes and can affect your vision. So I may not... that probably will never get better unless I maybe get a lens replacement. The other, genetic changes, gene expression that changed or changed as a result of your time in space. Now, I don't know if those changes are good or bad. Probably maybe never find out, but there are those kind of impacts as well.
Tell me, Scott,
there's also, though, the good thing, and that's the perspective on the planet.
Yeah.
I mean, I think your perspective changes when you get to see the Earth from space, see how, the Earth was meant to appear incredibly beautiful and peaceful, small, I think, than we may think. It seems like we are much more interconnected as humanity when you look at the Earth from space. So you get those kind of changes in perspective as well.
Certainly experiences that none of us could actually feel unless you've been up there. But that brings me to the question. We're living in a really exhilarating age of space exploration. But I want to ask you, why is space so important? I mean, why can't humanity be happy with Earth?
Well, I think we should be very happy with Earth, but understand if we are able to utilize the space environment for certain things, it makes life on Earth better. I mean, this thing wouldn't work the same way if it wasn't for satellites in space. I mean,
but why deep space? Why do we need to go to Mars? Why do we need to conquer Moon?
Yeah, we still have a lot to learn from going back to the moon, whether it's the geology of the moon, how the moon evolved, where it came from. Also, the moon is a great place to learn to go to Mars. Having said that, I am not a believer in this premise that we need Mars to be habitable as a lifeboat to go to if planet Earth is destroyed. I think no matter what we do to this planet, and I hate to imagine what we could do, which is pretty horrible, but even that, it would always be easier to live here than on on planet Mars that has no atmosphere, no liquid water, very few resources. Having said that, I still am a big believer in going to Mars because there's so much we can get out of going. We can learn what happened to Mars, so maybe we can help prevent that same thing happening to Earth. the technology we develop to go to Mars is useful for improving life on Earth. There are reasons of exploration. I mean, it's in our genetics that we are explorers. It's what we do. If we weren't explorers, we would have never, humanity would have never ventured out of Africa, as an example. And if all those things I said were wrong, if the only thing we got out of the investment of going to Mars, that it would inspire children to study math and science and become scientists and engineers and people that want to do hard and challenging things, if that is the only thing we got out of going to Mars, then that would be worth every penny, because those kids are not, all those kids, I mean, some of them will, but all of them are not going to work in the space program. All of them are not going to become astronauts, but they're going to do some incredibly important things that we really have challenges, problems to solve on Earth with regards to like climate change, healthcare, how do we responsibly use artificial intelligence, robotics. There are so many things to learn that we will learn from going on these missions that will absolutely improve life on Earth. And for that, every penny is worth the investment.
All right. On that note, Scott Kelly, thanks a lot for speaking to us. Let's wait and see what the space field has in store for us. Certainly exciting times, both in terms of AI and in terms of space exploration. So both of them are going to collide at some time in future. Thanks a lot for watching.